Okay, let's just jump right in. We're going to talk about something that starts with a pretty unpleasant memory that I think we all share, and it ends in this wild, high-tech reality that's totally changing the game in dentistry. We're talking about finally saying goodbye to those goopy, gag-inducing molds and saying hello to the digital impression. Oh man, you know the feeling, right? That big, cold metal tray, the gooey paste slowly inching its way toward the back of your throat, and you're just sitting there staring at the ceiling, trying not to gag, just praying for it to be over. It's a universal dental nightmare, and I don't know anyone who looks back on it fondly. So, what if we could just delete that entire memory? What if we could replace all that mess and all that stress with something that's not only fast and comfortable, but actually fascinating? Well, guess what? That's not science fiction. It's happening right now. And the hero of this whole story is this little device called an intraoral scanner. Now, this isn't just about replacing the old goop. It's about completely flipping the script on the patient experience. You're no longer just a passive person in a chair. You actually become an active co-pilot in your own dental care. And when you see it laid out like this, the difference is just night and day. It's not just about comfort. It's a huge psychological shift. I mean, instead of just laying back and hoping for the best, you're watching this incredible, high-res, 3D model of your own mouth get built in real time, right there on the screen. It's this wow moment that builds so much trust and helps you actually understand what's going on. So, how does this magic wand actually work? Well, it might look like your dentist is just kind of waving it around in there, but it's anything but random. Every single movement, every little twist and turn is part of a very specific, engineered path designed to build a flawless digital blueprint of your jaw. The scan actually follows a super logical path to get the whole picture. It starts with the palate, the roof of your mouth, then it maps out all the biting surfaces of your teeth, and finally, it scans the sides. But what's really amazing is that the whole time, there's this powerful AI working in the background, cleaning everything up on the fly. It knows to ignore your tongue and your cheeks, which is just incredible. But you might be wondering, why start with the palate, especially if you're just getting work done on one tooth way in the back? Well, the reason is actually brilliant. Your palate, with all its unique ridges, is basically a fingerprint for your mouth. It's a solid, bony structure that never changes. So by scanning that first, the dentist creates this permanent GPS coordinate. It's a fixed point they can always come back to, even years later, to track tiny, microscopic changes. And that real-time AI cleanup is so important. Think about it. The lower jaw is, well, it's a pretty chaotic place, right? You've got your tongue moving around, your cheeks, saliva. The scanner's AI is smart enough to tell the difference between the hard, stable surface of a tooth and the soft, wiggling tissue of your tongue. It just filters out all that digital noise instantly, leaving a perfectly clean model. Okay, so that's all great for a mouthful of teeth. But what happens in the really tough cases? What if there are no teeth at all to guide the scanner? This, my friends, is where the tech and the techniques get really clever. For a jaw with no teeth, which is a really tricky landscape to scan, dentists have these ingenious workarounds. Sometimes they'll stick tiny little markers on a patient's existing denture and use that as a guide. Or they might create a custom wax model that fits perfectly. In other cases, they'll even use a special tool that gently holds the tongue and cheeks out of the way to create a nice, clear path for the scanner to follow. It's pretty smart stuff. Alright, so now we have a perfect 3D model of the upper jaw and a perfect 3D model of the lower jaw. Now comes the moment of truth. We've got to bring them together and see the story of how that person actually bites. So with the patient just biting down normally, the dentist does a super quick scan of the left side, then the right side, and then bam, you see it on the screen. The two separate 3D models literally just jump into position and snap together perfectly, creating an exact digital replica of that person's unique bite. It's such a cool aha moment. And this is where it goes from cool to absolutely mind-blowing. The software then creates what is basically a weather map of your bite. Seriously, look at this. It's a color-coded map that shows all the invisible forces. See those bright red dots? That's where you're biting down with really intense pressure. The green and blue spots? That's lighter, healthier contact. For the very first time, a dentist can see exactly why a certain filling keeps breaking. It's because it's sitting right in the middle of a high-pressure red zone. Now, once all this incredible data is captured, it has to be sent off to the dental lab, and it can be sent in two main ways. The first way, an STL file, is like a perfect architectural blueprint. It has all the exact shapes and dimensions, but it's just gray, no color. The other format, the PLY file, is more like a full-color, high-resolution photograph. And for cosmetic dentistry, where you have to match tooth shades and gum colors perfectly, that full-color file is an absolute game-changer.
So, we've gone from messy goop to this ridiculously precise 3D picture of your mouth, which is already incredible. But believe it or not, this is really just the beginning. The next big leap forward is where things start to sound like they're straight out of a sci-fi movie.
The next frontier is all about adding motion. So imagine not just a static 3D model, but a living, moving digital twin of your entire jaw system. A perfect replica inside a computer that can simulate exactly how you chew, how you talk, and how all the forces are spread across your teeth as you go through thousands of cycles. And that, of course, leads us to the ultimate question. If we have that level of data, if we can simulate everything, what if we could predict and prevent dental problems years before they even start? We're talking about shifting from just fixing things that are already broken to an era of truly predictive dentistry. An era where we can see that a tooth is going to crack 5 years from now and intervene before it ever happens. This isn't just an upgrade, it's a complete revolution in healthcare, and it is just getting started.